All right, the very first thing on here goes back to the very first piece of chapter 7. We did not, I just said, that's annoying. Okay, we did not do a lot of it, so there won't be a lot on the test, but we did an example in class. There was one on our homework packet, there was one on the review packet, there was one on the study guide, so you will have one of these questions on your test. When I say something is a uniform distribution, that means everything has the exact same probability. So your graph looks like a rectangle because all the probabilities are the same. Your graph does not have to be anything fancy. So we are starting it at 63 and ending at 90. It doesn't necessarily have to be drawn totally to scale. I'm going to start at 60 and count by 5s. So we have a rectangle starting at 63 and ending at 90. The biggest issue with these is figuring out what the height of this rectangle is. So remember, the area of this is the probability, and the total probability is 1. We find the area of a rectangle by doing length times width. So the total area has to be 1. The length, how far is it from 63 to 90? So if you divide, our width is 1 over 27. So that's how we get the height of the rectangle. So it's just 1 over however long it is. So if it started at 20 and went to 80, what would the height be? 1 over 60. Then we want the probability, but the probability is just this area. So the probability a day has a temperature exceeding 68. So that means we start at 68 and we're going to 90. So we're talking about this part of the rectangle. Okay, our rectangle is length times width. How far is it from 68 to 90? 22. Okay, times the height of it is 1 over 27. So you could say 22 over 27, or you can give me the decimal, whatever that turns out to be. Okay, then C, what's the probability? It is between 70 and 77. So, length times width, how far is it from 70 to 77? Times the 1 over 27, so 7 over 27, or 0.2593. Any questions about that? So I'll probably ask you to draw one and at least find one probability. Probability is just the area of the rectangle, length times width. Okay, number 2. This is the normal curve. So in a normal curve, the mean is the center. So what is the mean here? 140. The standard deviation, remember, is how far from the center to that first point. So this is from 140 to 145, so our standard deviation is 5. If at any point you get confused, make sure you tell me to stop. Number 3, average miles per gallon of a new motorcycle is normally distributed. So I already know it's normal. Anytime I'm talking about normal, we know we're looking at that nice bell-shaped curve. Mean 27.4, standard deviation 2.9. Draw a normal curve with the parameters shaded. So, just checking if you know what the normal curve is. The center is our mean, which was then standard deviation. So you do the mean 27.4 minus the standard deviation 2.9, and that gives us 24.5. And then we do the mean plus the standard deviation, so 30.3. So you're basically drawing the picture that I gave you on problem 2. just labeling. The mean is the center, then you add and subtract your standard deviation. Okay, and then I asked you to shade what would be between 29.3 and 23.7. So we're just roughly shading. 23.7 is a little bit below my mean. 29.3 is about here. So we are just shading in between. And I didn't ask you to actually find any probabilities. Just can you draw a picture? Then part B, I wanted you to interpret it. So, the interpretation, there's two ways. We can think of it as a probability. So the probability the average mileage is between 29.3 and 23.7 is 0.6419. Or you could say there's a 64.19% chance the probability is between those values. So we could think of it as a probability of a single motorcycle having that, or we could think of it as the proportion of the whole population. So we could say the proportion of motorcycles with mileage between 9.3 and 23.7 is 0.6419. So basically what I want you to realize there, these areas, you can either think of it as a probability or a proportion. Those are the two things it can represent. That has not been a huge emphasis for us, so if I did ask a question on those lines, it's probably worth a point. It's not something that we spent a ton of time on. Most of our scenarios, we were thinking of them as probabilities, just calculating the probability of something happening. All right, number 4. This was reading our curves. So everybody flip to your normal table. Probably the worst part is the normal table and the T table are really set up opposite from one another, which is probably the thing that makes it the most confusing. If I'm talking about the normal table, if you look at the picture at the top, it tells you, it gives you area to the left. So when I say to the left of z equals 1.23, the z are those gold numbers. So you go down to 1.2, over to 3, and you get 0.8907. Everybody do that. Make sure you're getting that number, and if you're not, let me know. So we definitely spent a lot of time reading this table, so we're definitely going to have some of those in the past. How do we find area to the right? Okay, so then I look up negative 0.74, 0.2296. And then we subtract those. Get 0.7704. How do we do between? Subtract. But what you have to remember, your probability has to be a positive number, right? Between 0 and 1. So let's do the bigger one minus the smaller one. So we look up the 2.15, and its probability is 0.9842. We look up the negative 1.84, and that's 0.0329. And then we subtract them. Please, on the test, write down the two numbers. So this would probably be worth a couple points because you have a couple things to look up, and if all you write down is your final answer and you got it wrong, then I can't give you any points. But I could look at this and say, oh, you had the right numbers, you just subtracted them wrong. So please show me what you're doing on those. Are we okay with reading the normal table? Number 5, the Z alpha notation. So this does the opposite. It gives us area to the right. So it's saying draw a curve where the area to the right is 0.34. And what you're finding is the Z. Now, our table gives us area to the left. So if I'm going to find this, I need the area to the left. So 1 minus 0.34 is 0.66. This is your probability. So you are looking inside the table to find as close as we can get to 0.66. Alright, so the closest is 0.6591. So that Z is 0.41. So this one requires us reading the table the opposite of what we have been. Are there questions on that?
Are you okay if it was 0.415? Since it's 6591?
Yeah, that would be fine if you did it in between the two values. So I'll definitely put a Z alpha question on there. Are you okay with that? Then we got into actually starting to calculate some probabilities. So we have in 2008, the average ACT science score was 20.8 with a standard deviation of 4.6. Assume the scores are normal. So I know it's normal. These are just our basic when we were back calculating the probability. So if I want to find the probability a student has a score of at least 25. So I'm finding probability their score at least 25. Right, I'm not talking about a sample mean or a sample proportion. This is just our straightforward, back where we began. So we have to do what? We always need the Z. Yeah. So remember how to find your Z. If you forget it, it's on your formula sheet back under chapter 3. So Z is X, which is our value, minus the mean, which was 20.8, divided by the standard deviation, 4.6. So we're finding that Z. Make sure when you put this in the calculator, put that in parentheses. So this means we are finding the probability that Z is greater than 0.91. And then how do we get greater than from our table? 1 minus. So we have our Z, we look up 0.91, and that is 0.8186. So we get 0.181. Am I going too fast? Are you guys able to keep up? So these were back at the beginning. We know it's normal, just change it into a Z and find our probability. So B, I want to calculate the score is between 20 and 26. So what do we need to do with that? We need the two Z's and we'll subtract them. So each Z. So our value, so 20, minus the mean, 20.8, divided by the standard deviation of 4.6. So remember, we're subtracting these probabilities. You need to do the bigger one first. So if we look up 1.13, we get 0.8708. We look up negative 0.17, we get 0.4325. If we subtract, that is 0.438. And C, find a populated student has a score less than 16. So again, change it into a Z. R value minus the mean divided by standard deviation. So that means Z is less than negative 1.04. Less than is what our table gives us. So negative 1.04 is 0.1492. All right. Any questions on problem 6? Problem 7 is the same. Would it be okay if I skip that one for now and come back to it if we have time? So it's just a straightforward, we are told it's normal. I give you the mean, the standard deviation, so you're just finding your Z's, getting your probability. So that is like the first page and a half of your test is the stuff we've covered so far. Knowing what your normal distribution is, so there'll be a uniform question, there'll be a Z alpha question, just reading some from the table, and then our basic changing X's into Z's and calculating probabilities. Okay? Then we start getting into some different stuff. So if I look at problem 8, we have the charge life of a certain battery is normally distributed, mean 90, standard deviation 35. So part A is the same as what we were doing. We want the probability that a randomly selected battery, so that's just our X, is more than 100. So this is the same. We have to change it into a Z. R value minus the mean, which was 90, divided by the standard deviation, which was 35. So that means Z is greater than 0.29. How do we do greater than? 1 minus, and then look up 0.29. Make sure you're showing me all the work. This is what we're trying to find. Here's my Z, there's my probability, here's my final answer. Then I switch and I start talking about the sampling distribution for X bar. So on the test, I am going to be pretty straightforward. I am going to tell you, if I'm looking for the sampling distribution of X bar, the first question is probably going to be this. Describe the sampling distribution of X bar. So you see that X bar. So that tells me on my formula sheet, I need to go to my X bar stuff. Really, the only thing that you have to remember on these is your criteria. Everything else is either, or is on our formula. Okay, so we have different criteria when we're talking about X bar and P hat. With X bar, the criteria is either the population is normal or n's greater than 30. With p hat, my criteria, I have two things. N times p times 1 minus p is greater than 10, and my sample is less than 5% of the total population. So that is like the thing that you have to remember that is not on your formula sheet. The only time I'm going to make you write that down is if I say describe the sampling distribution. When I say describe this, I'm looking for three things: criteria, mean, and standard deviation. So describing the sampling distribution, I want those three characteristics. So the criteria, we're talking about X bar. So either it has to be bigger than 30, which it's not, or the population is normal, which I told you. So you can just tell me it's normal. Okay, we're talking about the mean for X bar. So if we look on our formula sheet under chapter 8, very first thing it says the mean for X bar is equal to what? The original mean, the mean of the population, which is 9. And then it tells us the standard deviation for X bar is our original standard deviation divided by the square root of 10. So 35 over square root of 10. 97, so 0.06. Okay. So if I ask you to describe a sampling distribution, what three things do I want? Criteria, mean, standard deviation. Now, part C, I want the probability that a random sample of 10 battery has a mean charge life of more than 100. I'm no longer talking about a single battery. I'm talking about in my sample, it's more than 100. So the idea is the same. We always have to change these into z's. The key is I'm now talking about X bar. So to change it into z's, I have to use the mean and standard deviation of X bar. So our z is our value minus the mean divided by standard deviation. So that's the probability that z is greater than 0.90. Depending on how many decimals you kept on your standard deviation, it could be slightly different. So make sure you are just writing that down so I know how many you had. Okay. And then how do we do greater than? 1 minus. So I look up 0.90, and that is 0.8159. Oh yeah, if I could subtract, that would help. Any questions there? So it's the same thing, but we're talking about X bars because I have a sample. So the probability that the sample mean has a charge less than 92. So the probability that X bar is less than 92. So again, change it into a z. Since the variable is X bar, we did the mean and standard deviation for X bar. The mean was so that's the probability that z is less than 0.18. Less than is what our table gives us. So if we look up 0.18, we get 0.5714. So if I'm talking about X bars, you need the mean and standard deviation for X bar when you find your Z. Is that okay? Alright. So moving on, problem 9. So again, this one is dealing with X bar. So would it be okay if I go through the others and I come back to this if we have time? So it's going to be just like problem 8. Okay, number 10. So we have approximately 22.4% of adults are smokers. A random sample of 300 adults is obtained. Describe the sampling distribution of p hat. If I ask you to describe the distribution, what am I wanting? The criteria is the thing we have to know because it's not given to us. I'm not going to be like super picky on what you show me here, but you have to show me enough that I know you looked at it. So my N is 300 times the P, 22.4%, so 0.224. 1 minus 0.224. I need that to be greater than 10. So just a quick check. So that's 52 something, so that's definitely bigger than 10. We're good there. The other thing is 300 less than 5% of all adults. Yes. So you can tell me N is less than 0.05, and you can tell me less than 5%, just something so I know you thought about it. Okay. Then, the mean. Look at your formula sheet. We're in chapter 8. My variable is p hat. So everybody make sure you can find it on here. Chapter 8, we have 3 bullets. The first one is mean standard deviation for X bar. If we're excited, we have the mean standard deviation for p hat. What is our mean? P, which is 0.224. Standard deviation is the square root of p, so 0.224. 1 minus 0.224 over N, and my N was 300. So we get a standard deviation of 0.0. You guys okay with that? Now if I've had you describe it, that's what we're using on these. In a random sample of 300, what's the probability that at least 50 are smokers? Okay, we already know from part A, I'm talking about p hats, which means I need a percentage, right? Did I give you the p hat in this problem? No. How do we find p hat? P hat is x over n. That's the other bullet in chapter 8. So my x is 50. N is 300. 50 over 300 is 0.1667. So we're finding the probability that p hat at least, so greater than or equal to 0.1667. What do I need to do with that? So, I have to change my variable into a z. Since this is p hat, we're using the mean and standard deviation we found for p hat. So our value minus the mean, divided by standard deviation. And we get z is greater than negative 2.38. Greater than is 1 minus we look up negative 2.38 and we get 0.0087. So 1 minus that is 0.991. So would it be unusual if 18% or less? So we're finding probably it's a percent, so that p hat is less than 18% would be 0.18. So we need our z, so our value minus the mean divided by standard deviation. Probability that z is less than negative 1.83. Less than is what our table gives us. So we look up negative 1.83. We get 0.0336. So, is that unusual? Yes. What's the definition of unusual? Anytime it's less than 5%, we can say it's unusual. Are we okay with p hat? So that's question 11 is just like that. So I'll skip that for now, come back to it if we have time. Let's talk about problem 12. As far as I'm concerned, when we talked about these confidence intervals, I showed you how to do them by hand, but I also told you you were free to do them on the calculator. So you can do it on the calculator on your test. But you need to show me enough that I know what you were looking at. That way, if you get the wrong answer, you're not just losing all the points. So when I'm looking at this, our confidence intervals, we have two options. We're going to go stat, test, and then we either use letter A or number 8. When do we use A? Yeah. Yeah, and if we look at them, it tells us stat, test. Letter A is when we're talking about the Z interval versus number 8 is the T interval. So A, the Z interval is when we're talking about p hats. 8, the T is when we're dealing with x bar. So you can do them on your calculator, but you have to know which is which. If you forget, you can look back on your formula sheet under chapter 9. It tells you the first bullet for making the confidence interval around p hat. It's p hat plus or minus z. So we know we're doing the one that involves z. Second bullet for x bar, it's x bar plus or minus t. So we're doing the one that involves t. You'll also know if you pick the wrong one because it'll ask you to type in information that you don't have. So that's probably a pretty big indicator. So if I want the confidence interval here for the population proportion means p hat. So I am going to stat, test, A. All right, and then at the very least, you might just tell me, like, this is the test I went to, here's what I typed in. So what's my x? 80. What's my n? The C level, 0.98 because it was 98%. And so then it tells me my interval is 0.3194 to 0.4806, depending on how you round. If you did it by hand, you might have only got your last digit might be slightly different because things are rounded a little more. I don't care which one you do. but you are free to do the calculator. It's probably the easiest option, and it's really what we did most of the time when we were doing these in class. Is that one okay? All right, let's look at problem 13. A poll found that 768 of 1,024 adult Americans stated that a candidate's positions on issues of family values are extremely important. Obtain a point estimate for the proportion. What am I asking you to find? P hat. P hat is X over N. So 768 over 1,024. Gives us 0.75. Okay, verify the requirements for constructing a confidence interval for P are satisfied. I'm asking you to check the criteria. Okay, criteria are the same as what we have over here. So we have N, which is 1,024, times P. Since we don't have the actual P, we're doing our P hat here, so 0.75. 1 minus 0.75. Has to be greater than 10, and it is. It's like 1,000 or 192. The other thing we need to check, would 1,024 be less than 5% of all adult Americans? So again, you don't have to show me a lot, but enough that I know that you understand the requirements. The only time you have to check the criteria on the test is if I specifically say check the criteria or describe the sampling distribution. Otherwise, I won't make you verify it. So construct a 99% confidence interval. So we can do it by hand, but we can do it on the test or on the calculator. Stat, test. We're talking about P hat, so that is letter A. So my X is what? In. And our sea level, 0.99. And it gives me 0.7151 to 0.7849. Okay, so this means I am 99% confident. The value is between 71.5% and 78.5%. Is it possible to be less than 70? Yes, I am not 100% confident. So it can fall outside this interval every time. We will never be 100% confident. So it's always possible to have something that doesn't work. But is it likely? No. There is only a 1% chance that you do not fall in here. So it is extremely unlikely to have a value of 70%. But you can. It is possible. Let's see if we can get through the last couple here. A school administrator wants to estimate the percentage of full-time college students who have credit card debt of $2,000 or more. What sample size? So go to your formula sheet. I'm talking about sample size. So under chapter 9, the right-hand column has sample size. If she wishes the estimate to be within 2.5% with 94% confident, if part A, the pilot study indicates the percentage is 34%. So that means my P is 34%. Okay, so that's when we're looking at this formula, we have a P. So that means we can use the first formula. P hat, 1 minus P hat times D alpha over 2 divided by E squared. So P hat is the 0.34. 1 minus P hat, so 1 minus 0.34. Okay, let's talk about this last bit. E is our error. If it's 2.5%, then we would do 0.025. The Z, we are going to have to use our table to find the Z. We are talking about a confidence interval, so we want 94% to fall in the middle. So we have 6% left, right? 3 for each end. We are looking for this Z right here. So if 3% is to the right, how much is to the left? This is 97%. So you have to find the Z that matches when our probability is 97%. So we're going to the Z table. We're looking inside as close as 0.97 that we can get. So that looks like 0.9699. And that is when my Z is 1.88. What? Did I? So then we type this in. We get 1268.99. We always round this up, so it's 1,269. That would. Right. Hardest part about that is finding the Z. Does everyone understand where I got that? For part B, we're doing the no prior estimate. So if you keep reading under that same bullet on your formula sheet, it gives you the first formula if you have P, and then it says if you don't have P, do this. N is 0.25 times Z alpha over 2 divided by E squared. We already have all of this from above. Z alpha over 2 is the 1.88, E 0.025 squared. We get 1.76, 1,400. Don't have a ton of time. So let's check. We've skipped like 6 questions. Do we feel like we still want to go ahead with this test tomorrow? Everybody's good with that plan? Okay, so what I'm going to do is I will post the answer key to the study guide on Google Classroom. So that way you can finish the last 2 questions and check them. And then that also gives us a good opportunity because there's one when it's X, one when it was X bar, one P hat, so you can practice all the different types. So do the problems we haven't done yet. I'll post the answer key so you can check it. If you need help, come see me. If you can't come see me, email me. If for some reason you feel like you're not ready tomorrow, I will make other arrangements with individuals if we need to. Okay, so if somebody doesn't feel ready, just talk to me and we'll set up something else. All right? So I will post that, and then please